Jai Hind, one and all present here. I am Nandini Sharma, Assistant Professor in Department of Pharmaceutical Chemistry, Kharpel College, Subharti, Swami Vivekanand Subharti University. Now, I would like to thank our Honorable Vice Chancellor, Retired Major General, Professor Dr. G.K. Thapliyal Sir, and Honorable Chief Executive Officer, Professor Dr. Shalyaraj Ma'am, for their blessings for the webinar. Due to some reason, they are not able to join us. We all are gathered here for a webinar on topic mixed solvency concept, which means a solid shall be alternate source to replace harmful organic solvents in future. For this, we have eminent speaker, Professor Dr. R.K. Maheshwari Sir. We are in process to start our seminar, so I would like to request all the participants to be with us, and if anybody have queries regarding this session or during this session, they can ask in the chat box. Now, I would like to request our respected principal, Professor Dr. Sukendra Kumar Sir, to welcome our speaker, Professor Dr. Maheshwari Sir, and give the brief overview of today's webinar. Please, sir.
Okay, thank you, Nandini. Jai Hind, everyone. On behalf of Faculty of Pharmacy, Swami Vivekanand Subharti University, I welcome Dr. R.K. Maheshwari, the eminent speaker of the webinar, all the participants. And then thank you, sir, for your kind gesture. You have accepted our invitation and you have given your consent, and today you are in the webinar. Coming to the today webinar topic, that is a mixed solvency concept. It is a novel concept, and you are the leader in this concept. Actually, mixed solvency concept is used to enhance the solubility of the poorly aqueous soluble drugs. Around 40% NCE, new chemical entity, have major concern with the solubility. So there are several approaches which are used to improve the solubility of the poorly soluble drug, like hydrotrophy, mixed hydrotrophy, and mixed solvency. So sir is expert in mixed solvency. तो हमें ज्यादा जरूरत नहीं है कुछ बताने की कि मिक्स सॉल्वेंसी में क्या करना है. सर इज द एक्सपर्ट एंड ऑलराउंडर इन दिस कंसेप्ट. तो लेकिन थोड़ा मैं ब्रीफ बताना चाहूंगा अपने सभी साथियों को यहाँ पे कि जो डिफरेंट अप्रोचेज हैं, जैसे हाइड्रोटॉप्स से विद द हेल्प ऑफ हाइड्रोटॉप्स वी कैन इंप्रूव द सॉल्युबिलिटी, एंड हाइड्रोटॉप्स आर यूरिया, सोडियम बेंजोएट, सोडियम साइट्रेट, and nicotinamides. Water soluble solids can also be used to improve the solubility, like PEG 4000, PEG 6000, and the co-solvent propylene glycol, glycerin. So today we are with the expert Dr. R.K. Maheshwari. Now I request to Dr. R.K. Maheshwari, before going to start this webinar, please, Nandini, over to you.
Thank you, sir. Now I would like to call Professor Dr. Ganesh Prasad Mishra, sir, to introduce Professor Dr. R.K. Maheshwari, sir.
Thank you, Nandini. Jai Hind to all. No need to introduce our well-known speaker, but as a protocol event, I would like to introduce him, Professor Dr. R.K. Maheshwari, sir. He is currently working as a professor, Department of Pharmacy, SGS Indore, Madhya Pradesh. He has 33 years of teaching and research experience so far, and he is a member of several affiliated government bodies. He has published more than 150 research papers, national and international reputed journals. So far, he delivered more than 300 expert lectures in India and 15 expert lectures out of India. He has guided more than 75 M.Pharm students and 3 PhD students so far. Apart from that, he has filed 5 patents so far. Respected sir, I welcome you.
Thanks a lot, sir, for sharing about the speaker. Now, I would like to request our speaker for deliver his talk.
Because of whose effort I am here with you to share the research ideas to all of you, students as well as teachers. So what you shall get in my lecture, let me explain that thing to you. In my lecture, you will find the methods by which we can minimize the use of harmful organic solvents. And particularly, we shall utilize the solubilizing power of safe and economic solids to replace harmful organic solvents, because solids also possess solubilizing power. This you will get in my lecture. Okay, now I am starting my presentation. I am sharing the slides. Is it visible? आप लोगों को दिख रहा है?
Yes, sir.
So it is visible, okay? Or is it changing also? Okay. So now, more or less, today's object or title or topic is solubilizing properties of solids shall replace harmful organic solvents. Organic solvents, something about the organic solvents, because so many students are there, they should know where we use these organic solvents. So various organic solvents are employed in various analytical techniques like TLC, HPTLC, HPLC, UV spectrophotometry, titanometry, etc. In extraction of active constituents from herbal powders, in the synthesis of organic compounds, in formulation of pharmaceutical dosage forms, in identification tests of drugs, etc. Drawbacks of organic solvents, they include, say, organic solvents have innumerous adverse effects caused by single exposure, like dermatitis, headache, drowsiness, nausea, irritation, etc. Long-term exposure of with means if a analytical chemist or any say formulation chemist is there and if they are exposed to vapors of organic solvents for long duration of time, means for several say, months together, years together, then what harm can be there to their bodies? The serious ill effects, they include neurological disorders, chronic renal failure, liver damage, neurosis, mutagenesis disorder, etc. So not only they are injurious to our health, hazardous to our health, but also organic solvents are costly and their disposal requires a special treatment after their use. Means when after use these organic solvents are thrown away from the industries, from the institutions in large amount, then they are given a particular treatment. So that treatment again involves a cost, means again the use of organic solvents is made more costlier. Now, some classes of organic solvents should be known to students. There means I will talk about the three organic solvents, these classes of organic solvents. Class 1 organic solvents, they include benzene, which is carcinogenic, carbon tetrachloride, very hazardous to our health, 1,2-dichloroethane, etc. They are also very harmful for human being, means they are vapors. When these vapors are inhaled by the human being, they are very harmful. Class 2 organic solvents commonly employed, they are acetonitrile, chloroform, toluene, methanol, pyridine, hexane, dimethylformide, etc. So, okay, students, they are understanding where these organic solvents are used in analysis, formulation, synthesis, extractions, etc. Class 3 organic solvents commonly employed, they include acetic acid, acetone, ethanol, ethyl acetate, etc. And out of these class 1, 2, 3 organic solvent categories, Class 3 organic solvents, they are relatively safer. They are safer than class 2 and class 1 organic solvents. Class 2 organic solvents are safer, little bit safer than class 1 organic solvent. Means you may say class 1, they give most harmful effects for the health of human being. And class 3 are, out of these, they are safer. Okay. Now, future role of solvent character of solids. Solubilizing power of solids shall minimize the use of harmful organic solvents in future. Class 3 organic solvents are relatively safer than class 2 and class 1 organic solvents. We can potentiate the solvent power of class 3 organic solvents by dissolving safe solids in them to replace class 2 and class 1 organic solvents. These examples, I will give 1 or 2 examples that how can you potentiate the solvent power of class 3 solvents which are safer than class 2 and class 1 by use of solubilizing power of solids. Class 3 organic solvents can be made as strong in solvent character as class 2 or class 3 organic solvent. Dissolution. What happens in the dissolution? Dissolution of a solute in a solvent involves hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. So students should understand what happens in dissolution. Suppose you are dissolving, say, metformin hydrochloride in water. It is a water-soluble drug. So you are getting a solution of metformin hydrochloride in water. How you are getting a solution? Because of, as a result of hydrogen bonding and weak van der Waals forces between the molecules of metformin hydrochloride and molecules of water. If you are dissolving, say, for example, ibuprofen in chloroform, for example, you are getting a solution. Why you are getting a solution? As a result of hydrogen bonding and weak van der Waals forces between the molecules of ibuprofen and molecules of chloroform. So always in dissolution, there is involvement of hydrogen bonding and weak van der Waals forces. Okay. Mixed solvency concept, which was proposed by me first time in the world in the year 2009. The first parameter of them is, there are 2 parameters. First parameter of this mixed solvency concept says that each and every substance, gas, liquid or solid, present in this universe has got solubilizing power. Each and every substance means whether the substance is gas, whether the substance is liquid, whether the substance is solid. All substances present in this universe have got solubilizing power. Only thing will be how the gases will demonstrate their solubilizing power or how the solids shall demonstrate their solubilizing power. When the molecules of gases are the molecules of solids, when they are in liquid state, then they can also be involved in hydrogen bonding and weak van der Waals forces to dissolve the solute. So these examples I will give in my lecture. And what I want to say here that just like the so-called solvents, you know, whatever the matter exists in the form of liquids, they all are known as solvents. For example, water, polyethylene glycol 400, propylene glycol, glycerine, fixed dyes. Okay, so many substances, they are available in liquid state at room temperature. So these substances are, you may say, these liquids are called solvents. But no solvent is universal solvent, means no solvent dissolves all substances in large amounts. So in other words, we can say whatever the name of any solvent you take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Just like water, as we know from the books, from the literature, that about 1/3 of the drugs, they are water soluble, about 2/3 of the drugs, they are water insoluble. This means water is good solvent for some 1/3 drugs, say, and water is bad solvent for 2/3 drugs, other solutes like this. So same is this statement we will have to remember to know how the gases and solids also possess solubilizing power. And in mixed solvency concept, all the molecules present in this universe have got solubilizing power, and all molecules, whether they are the molecules of gas, liquid or solid, all molecules possess good solubilizing power for some solutes and bad solubilizing power for other solutes. And now I am reading from the slide. Once the molecules of a gas, molecules of a solid come in liquid state, they may also be involved in hydrogen bonding and weak van der Waals forces with the molecules of solute for their dissolution. About solvents, Whatever matter exists in liquid state at room temperature is known as solvent. I have told you. Each liquid or the so-called solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Similarly, each matter, whether matter is liquid, gas, or solid, is known as solubilizer in mixed solvency concept. Molecules of all solids, in particularly in liquid state, and molecules of all gases in liquid state also possess good solubilizing power for some solutes and bad solubilizing power for other solutes. Before giving the examples of solids, that how can we say that solids possess solubilizing power, let me explain that how the gases possess solubilizing power, because that is not there in this presentation. So how a gas can behave as solvent when the molecules of a gas come in liquid state, and the molecules of a gas may come in liquid state by two ways. Number one, by liquefaction. Number two, by dissolution in a solvent. Now I will give examples of both. If you liquefy a gas, just like in supercritical fluid technology, which is running in this universe, it is being used for the extraction, for the purification, for the you may say the formulations of nanoparticles, etc., like this. So in supercritical fluid technology, liquefied CO2 gas, after a particular pressure and temperature, when CO2 is liquefied, in liquefied condition, this liquefied gas means CO2 is being used as solvent to carry out different functions in supercritical fluid technology, like preparation of nanoparticles, extraction of active constituents from herbal powders, purification of the materials, and so on and so forth. So ultimately a gas means CO2 after liquefaction is acting as solvent. Why it is acting as solvent? Because in liquid state, in the liquefied condition, CO2 molecules, they are there in liquid state. These molecules of CO2 are involved in hydrogen bonding and weak whatever forces with the molecules of solutes, etc., like this. And this liquefied CO2 is also not good solvent for each and everything, because sometimes when the solvent character of CO2 is poor for some of the solutes, in those cases you have to use another, say, other co-solvents like ethanol, methanol, etc. So in this way, now you may say that liquefied CO2 is good solvent for some substances and bad solvent for other substances where you require a co-solvent to increase its solvent power. So in this way, it has been proved that liquefied CO2 is a solvent. Now another example means by which the molecules of a gas may come in liquid state is by dissolution. For example, our concentrated hydrochloric acid contains about 38% weight of dissolved HCl. Means 100 grams of concentrated hydrochloric acid contains about 38 grams of dissolved HCl gas. And dissolved HCl gas means molecules of gas, they are in liquid state. The solubility of nalidixic acid in this concentrated HCl is about 5%, means soluble category, 5%, very good solubility of nalidixic acid. We are not making any formulation, but we are seeing a proof that gases have got solubilizing power. Otherwise, this nalidixic acid is a poorly water-soluble drug. Poorly water-soluble drug, but here in concentrated HCl, the solubility is more than 5%. This means the molecules of HCl which are present in liquid state in concentrated HCl, they are increasing the solubility of nalidixic acid due to hydrogen bonding and weak van der Waals forces with the molecules of nalidixic acid, like this. So these two examples are there by which the gases molecules can come in liquid state. Now after gases, but the utilization of gases for their solubilizing power is a costly affair, so we are keeping them aside. Mostly in my lecture, you will find that economic use of solids, of safe solids, can be used to minimize the harmful, the use of harmful organic solvent. Now, so before giving the examples, eco-friendly examples or green, and say you may say examples, green chemistry of these solids, let me explain how can you say that solids possess solubilizing power. One more thing. In my lecture, so many questions may arise in your mind during my lecture, so you can note down your questions. At the end of the lecture, I will give the answer for your questions. So do as many questions as possible. Now, how the molecules of a solid may come in liquid state? Number one, by melting. Number two, by dissolution in a solvent. Number three, by eutectic formation. Now the examples of melting, number one, for example, melted urea. If you take in your test tube 1 gram urea, you heat it on heating mantle. At the melting point of urea 132 degrees centigrade, you will have clear colorless 1 gram melted urea liquid, which can be shaken like any solvent. What you are getting? 1 gram melted urea at 132 degrees centigrade, a clear colorless liquid. Okay, in this liquid at 132 degrees centigrade, there is very good solubility of diclofenac sodium. It dissolves about 1 gram of diclofenac sodium. 1 gram. 1 gram melted urea, 1 gram diclofenac sodium. About 40-50% solubility is there. Diclofenac sodium has a melting point of 283 degrees centigrade. Means at 132 degrees centigrade, the melting point of urea, diclofenac sodium does not melt. Okay, you are getting a solution. Why you are getting a solution? What is the reason for this? The reason is that the urea molecules possess solubilizing power for this diclofenac sodium. Suppose there was no solubilizing power in the urea molecules, then you could have obtained a suspension. Okay, so this proves that molecules of urea possess solubilizing power for diclofenac sodium due to hydrogen bonding and weak van der Waals forces, just as we have understood in the case of solvents. Okay, due to hydrogen bonding and weak van der Waals forces. Okay, now we are not making any formulation at this time, only we are seeing the proof. Another example is that of phenol. Phenol melting point is 44 degrees centigrade, and your test tube 1 gram phenol is there, water bath. At about 44 degrees centigrade, you are having clear, colorless, melted phenol liquid, which can be shaken like any solvent. In this melted phenol liquid, nalidixic acid 500 milligram is nicely dissolved, means about 40% solubility is there. Why? What is the reason for this? The molecules of phenol, which are in liquid state, are involved in hydrogen bonding and weak van der Waals forces with the molecules of nalidixic acid. That's why you are getting a large solubility. We are not making formulation, but we are seeing a solid phenol in melted condition is acting as solvent. By dissolution in a solvent, the example number one is that of water solvent. Ibuprofen solubility in water is very poor, 0.028% weight by volume, very poor solubility. But solubility of ibuprofen in 2 molar sodium benzoate solution, 2 molar means 28.8% weight by volume sodium benzoate solution is 2.390%. Okay, so how many times solubility enhancement is there? 2.390 divided by 0.028. Means about 85-fold solubility enhancement is there. Why there is solubility enhancement? The reason is the molecules of sodium benzoate, which is solid at room temperature, when it is dissolved in water in this much concentration, of course, the molecules are present in the liquid state. And these molecules of sodium benzoate are involved in hydrogen bonding and weak van der Waals forces with the molecules of ibuprofen. That's why you are having large solubility of ibuprofen in sodium benzoate solution, concentrated sodium benzoate solution. So this is a proof that a solid is possessing solubilizing power. Number two example is that of ethanol solvent. The solubility of furosemide in ethanol is very poor, about 1.7%, sparingly soluble, 1.7% weight by volume. Okay, when we prepare 15% weight by volume niacinamide solution in ethanol, niacinamide is solid. When it is dissolved in ethanol, 15% concentration. In this particular solution, the solubility of furosemide is about 5%. So 5 divided by 1.7, about 3-fold enhancement in solubility there, 3-fold enhancement. What is the reason for this? When you have not added niacinamide, means when only ethanol was present, the solubility is 1.7% due to limited hydrogen bonding and weak van der Waals forces between the molecules of ethanol and molecules of furosemide. But when you have added 15% niacinamide, now the molecules of niacinamide are available in liquid state. So these molecules of niacinamide are also involved in hydrogen bonding and weak van der Waals forces with the molecules of furosemide. That's why remaining solubility is due to this hydrogen bonding and weak van der Waals forces. So in this way, this is again a proof that a solid, means niacinamide, possesses solubilizing power. Third example is that of propylene glycol solvent. The solubility of pyroxicam in propylene glycol is about 5 milligram per ml, 5 milligram per ml, nearly poor solubility. But when we dissolve two solids in propylene glycol, 10% sodium acetate, 10% sodium caprylate, two solids, so total became 20%. So when these two solids are dissolved in the 10% means total 20% in strength in propylene glycol, now the solubility of pyroxicam in this particular blend or mixed solvent blend is about 120 milligram per ml, 120 milligram per ml. So 120 divided by 5, about 24-fold enhancement in solubility is there. What is the reason for solubility enhancement here? Again, you will have to say that it is due to the reason that the molecules of two solids, sodium acetate and sodium caprylate, they are available in liquid state, and these molecules of sodium acetate and sodium caprylate are also involved in hydrogen bonding and weak van der Waals forces with the molecules of this is your pyroxicam. That's why there is a large solubility. So these all are the proof, although we are not discussing the formulation part at this time, but only the proof that how can we say that solids possess solubilizing power. Now, third way is by eutectic formation. Eutectic formation, suppose you take thymol and menthol 10 gram in a pastel mortar. With the help of pastel mortar, you triturate them, 10 gram thymol, 10 gram menthol. So you will get a clear colorless liquid at room temperature, and the pH of this liquid is 6.5. This liquid is known as eutectic mixture or eutectic liquid. So two solids, thymol and menthol, when they are triturated in equal ratio, you may say, then you get a liquid. Now the molecules of thymol and molecules of menthol are present in liquid state in this eutectic liquid. The properties of this eutectic liquid, if you take 1 ml of this eutectic liquid in your test tube, and if you are going on adding 10 milligram of metronidazole benzoate, you are shaking it as soon as you get solution. Again, you are adding 10 milligram, more than 200 milligram of metronidazole benzoate. Left hand side, please say metronidazole benzoate 200 milligram is nicely dissolved by 1 ml of this eutectic liquid. Means about 20% solubility is there, that of metronidazole benzoate in this eutectic liquid. Otherwise, this metronidazole benzoate is a poorly water soluble drug. Okay. Now, what is the reason for good solubility? Again, we are not making any formulation at this time, but what we are seeing, a liquid containing two solids, the molecules are present in liquid state, and now the molecules of thymol and molecules of menthol, they are involved in hydrogen bonding and weak van der Waals forces with the molecules of metronidazole benzoate. That's why you are getting a large solubility of metronidazole benzoate. Similarly, this eutectic liquid is good solvent for atenolol, ornidazole, benzocaine, udrazate, RSP, etc., etc. Right hand column, if you see cetronidazole, a poorly water soluble drug, 5 milligram. If you are adding in 1 ml of this eutectic liquid and you are shaking it for hours together also, all 5 milligram does not go in the solution. This means this eutectic liquid is poor solvent for cetronidazole. Similarly, this eutectic liquid is poor solvent for fusamide, nimesulide, aspartame, etc., etc. Okay. Similarly, if you see the solubility or miscibility of liquids in this eutectic liquid, left hand column, ethanol, propylene glycol, benzyl alcohol, etc., they are in large proportion, means there is very good solubility of these in this eutectic liquid. And on other hand, right hand side, glycerin and water. Glycerin is immiscible in this eutectic liquid, water is immiscible in this eutectic liquid. Similarly, if you check saying hundreds of compounds, thousands of compounds for solubility in this eutectic liquid, some will fall in this column, some will fall in this column. So what you can say now, you may say that this eutectic liquid or thymol menthol is good solvent for some solutes and bad solvent for other solutes. As in case of liquids, we have defined that whatever the name of any liquid, for example, water, ethanol, methanol, etc., you take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Similarly, this eutectic liquid possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. This means this eutectic liquid is a solvent. And once it is proved that it is a solvent, means whatever it contains two solids. These two solids must possess solubilizing power. That's why you are getting good solubility of some of the compounds. If suppose my methyl thymol molecules were not possessing solubilizing power, means all materials must have gone in the right hand column, insoluble type of compounds. Anyway, so these are again the proof. No question of any formulation at this time. Now, after seeing these proofs, now coming to hydrotropic solubilization. हाँ, यहाँ पर लाइट चली गई है तो थोड़ा अंधेरा आ रहा होगा, कोई बात नहीं, लेकिन आप लोगों को दिख रहा होगा सब. So some hydrotropic agents, this is the list gives some of the hydrotropic agents. Okay, now in this list I will explain from the point of view of students what do you know about the hydrotropic solubilization. So first example you see in the middle, nearly middle, that is urea. Means all these whatever you are seeing on your screen, all these salt type of substances, they are known as hydrotropic agent. Of course, this is a small list of hydrotropic agent. Okay, what happens in hydrotropic solubilization? Suppose you make 60% weight by volume solution of urea and water. This is a hydrotropic solution. How will you make from the point of view of student? 100 ml volumetric flask, 60 gram of urea, sufficient water, shaking for dissolution. When you get clear solution, make a volume up to 100 ml with water. So you will get the 60% weight volume solution of urea and water. Now the solubility of this of dichloromethane sodium in this particular urea solution is about 4.8%. 4.8% weight by volume. In water, the solubility of dichloromethane sodium is about 1.6%. In water, 1.6%. In concentrated urea solution, 60%, 4.8%. Threefold enhancement in solubility there. 4.8 divided by 1.3, 1.6. So about threefold enhancement in solubility is there. What is the reason for this solubility enhancement? Previously, when you were having solubility of dichloromethane sodium in water 1.6%, it is due to hydrogen bonding and weak van der Waals forces between the molecules of dichloromethane sodium and molecules of water. But when you are seeing the solubility in urea, now the urea molecules are also present in your solution. So these urea molecules, when means they are in liquid state, and these molecules also are involved in hydrogen bonding and weak van der Waals forces with the molecules of dichloromethane sodium. That's why you get large solubility. Anyway, but what is this? This is a hydrotropic solubilization. Hydro means water. When solubility enhancement in water or aqueous solution is there, we call it to be hydrotropic solubilization. Means solubility enhancement in oil, solubility enhancement in propylene glycol, nahi, not in other solvents, but only in water or aqueous solution. Okay, when there is solubility enhancement, it is hydrotropic solubilization, and this concept is about 100-old concept. Okay, now so this was one example, first example of hydrotropic solubilization. Number two, sodium citrate, left hand column, step sodium citrate. If you prepare 45% weight by volume solution of sodium citrate and water, in this concentrated solution of sodium citrate, the solubility of salicylic acid is about more than 15%. Otherwise, the solubility of salicylic acid in water is about 0.3% weight by volume. So 15 divided by 0.3, about 50-fold enhancement in solubility is there. In what is the why there is solubility enhancement? Again, the reason is sodium citrate molecules are available in liquid state for hydrogen forces with the molecules of this your salicylic acid. That's why large solubility is there. Hydrotropic solubilization. Sodium citrate is also a hydrotropic agent. Its solution is hydrotropic solution. Another example is weight by volume solution of sodium benzoate in water. This solution of containing concentrated, you may say, in water, in this solution, the solubility of several poorly water soluble drugs is enhanced, like that of ofloxacin, gatifloxacin, tindazole, metronidazole, naproxen, ibuprofen, flurbiprofen, nalidixic acid, pyroxicam, hydrochlorothiazide, then you have so many means things. Anyway, paracetamol, dichloromethane sodium. So the solubility of a large number of drugs is enhanced in concentrated solution of sodium benzoate. So these are also the examples of hydrotropic solubilization. Again, you listen, the students, particularly hydrotropic. So hydrotropic solubilization relates with solubility enhancement in aqueous solutions only, not in other solubility enhancement in other or in aqueous solution. Okay, now the definition of hydrotropic solubilization: when there is enhancement in aqueous solubility of a poorly water soluble drug, in the presence of a large concentration of an agent, then we call this phenomena to be hydrotropic solubilization phenomena. Now the applications of hydrotropic solubilization, there are so many examples, but I don't have so much time that I can show so many examples to you. But of course, one thing is there, if you need, whether you are a student or teacher, okay, you can ask me in the last, I will give my email ID, I will give my WhatsApp number. You ask me this PowerPoint presentation, so afterwards you can see it. Okay, now the applications of hydrotropic solubilization. Eco-friendly titematic analysis of poorly water-soluble drugs using hydrotropic solution without the use of any organic solvent. So example is that of furosemide API, active pharmaceutical ingredient, bulk drug, IP method, 2018 IP method or BP method, they are same. And what is that method? Furosemide is water-soluble drug. That's why for its dissolution, this pharmacopoeia is using dimethylfuramide. So what is the procedure for this? Weigh accurately about 0.5 gram furosemide API in 40 ml of dimethylfuramide in a conical flask. You get a clear solution. This DMF is a class 2 clear solution of furosemide DMF. Then few drops of bromothiamyl blue indicator is added, and it is titrated with 0.1 molar NaOH solution. 0.1 molar NaOH solution. So at the end point, when there is color change, you know the reading here. So the reading is V1 ml of 0.1 molar NaOH solution. V1 ml. Okay. Now carry out so you take you add 40 few drops of bromothiamyl indicator will turn 0.1 molar solution. As soon as you get color change, suppose x1 ml of NaOH is consumed for this color change, then you will note down this volume. Okay, this x1 ml has been consumed by your solvent. This will be separated from x volume of NaOH has been implied for your titematic analysis. What problem are you? हेलो आवाज आ रही है भाई हेलो
Yes, sir, you are audible.
हेलो आवाज आ रही है
Yes, sir. आ रही है सर आवाज.
अच्छा क्लियर आ रही ना आवाज है ना ओके 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 ठीक है चलिए सो व्हाट आई वाज सेइंग दैट x1 sorry v1 minus x1 ml has been consumed for your drug furosemide, and using the factor in the last 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of furosemide. Using this factor, you can find out the percent purity of your API furosemide. So this is IPBP method where there is involvement of dimethylfuramide, which is a class 2 organic solvent. Okay, now here I would like to explain how can you potentiate the solvent power of class 3 to act as class 2. Let me explain. Okay, now you see why Pharmacopoeia did not use ethanol in this titematic analysis, because ethanol is a class 3 safer organic solvent, but Pharmacopoeia could not use it. Why? Because the solubility of furosemide in ethanol was limited 1.7%. I have shown you. You see here the solubility of furosemide in ethanol. You see second number is 1.7%. Okay, it is sparingly soluble. So because of this reason, the ethanol could not be employed in this titematic analysis. That's why they were forced to use a class 2 organic solvent like DMF, which is of course harmful for human being, because their vapors are harmful for human being. So they could not use ethanol. But now you see here, in the second example again, 15% weight by volume nationwide solution in ethanol, the solubility is 5%. It comes under the soluble category. So what I have done, I have used this 15% weight by volume nationwide solution in ethanol in place of dimethylfuramide. So now you see here itself that in place of 40 ml of DMF, I have employed 40 ml of this solution, 15% niacinamide in ethanol. Okay, and there was a complete dissolution of furosemide in this, bromothiamine value indicator, and then titration with NaOH and blank determination. So what I have done in this way, by utilizing the solubilizing power of a safe solid niacinamide, I have potentiated the solvent power of ethanol to act as class 2 organic solvent like DMF. And I have made ethanol, which is a safer than dimethylformide. So I told you that how can you potentiate the solvent power of a class 3 organic solvent to act as class 2 or class 1 organic solvent. So this is one example of potentiation of solvent character using the solubilizing power of a safe and economic solid. Now, so I told you that this was one method. Using ethanolic solution of 15% weight by volume niacinamide, this was used in place of DMF, and 100% correct results were there. Okay, this was better than this one, because in place of DMF you are using ethanol. But still better method, now I will tell you, hydrotropic method. In that you do not require any solvent, no ethanol, no organic solvent. Now what is this hydrotropic analysis? Assay of furosemide by hydrotropic analysis or green analysis, you may say, or eco-friendly technique, you may say. In this particular technique, weigh accurately about 0.5 gram furosemide API, dissolve with the help of 40 ml of 30% weight by volume sodium benzoate solution, which is a hydrotropic solution, you get a clear solution. Few drops of bromothiamine value indicator is added in this particular solution, and then it is titrated with a 0.1 molar NaOH solution. Suppose the reading at end point is V2 ml of NaOH solution, then you will carry out a blank determination, another conical flask, neat and clean, 40 ml of sodium benzoate solution 30%, few drops of bromothiamine value indicator, you will run 0.1 molar NaOH solution. Suppose at end point the volume consumed that of NaOH is say X2 ml, so V2 ml minus X2 ml, this much volume of NaOH has been consumed by your drug. Using the same factor of pharmacopoeia, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of furosemide. You can find out the drug content. Now you see the beauty of this method. This is very economic method, and also it is eco-friendly, means without organic solvent. Sodium benzoate is not volatile. It does not harbor to the human being. Okay, and number two, it is cheaper. The solution of sodium benzoate 30% in water, weight by volume solution, costs about rupees 40 per liter. Otherwise, the cost of, you say, DMF, maybe 200, 300 rupees per liter. So others say class 2 organic solvent like methanol, this acetonitrile, DMF, chloroform, carbon tetrachloride, etc. They are 200, 300, or 400 rupees per liter. Okay, so here you are seeing just by the use of a safer solid like sodium benzoate, it is a hydrotropic method. We can replace harmful organic solvent. So without the use of organic solvent, you are performing the trichromatic analysis. If you have any question, please note down. At the end of the lecture, we will have discussion. Now, similarly, now I will run fastly. Flurbiprofen API, IPBP method involves the use of ethanol for its dissolution, NaOH titration. Here, we will use sodium benzoate solution in our green method or hydrotropic method. In naproxen case, API, methanol is used for its dissolution. Methanol is a class 2 organic solvent. This methanol has been replaced again by sodium benzoate solution in the same way as in case of furosemide. And one more thing, let me tell you, in these naproxen analysis method and furosemide analysis, I have shown there in IPC Ghaziabad, from where we get our IP, Indian Pharmacopoeia. In presence of me, they have carried out the trichromatic analysis of these two bulk drugs, and they have compared with their pharmacopoeial method, and the same results were there. So one day will come when these methods will come in pharmacopoeia also. It may take time, but they will definitely come in the pharmacopoeia. Salicylic acid API requires ethanol in IPBP method. Ethanol has been replaced by sodium citrate. It is again a cheaper as well as it is a hydrotropic solution. So cheaper hydrotropic solution is used for analysis of salicylic acid. Ketoprofen IPBP method, ethanol is required. Ethanol can be replaced by sodium benzoate solution in the usual way. Now ibuprofen API, ethanol is used in IPPP method. Ethanol has been replaced by sodium benzoate solution. Ibuprofen tablet, there is involvement of two organic solvents, chloroform and ethanol. Now these two organic solvents, they have been replaced by sodium benzoate solution. Just one time you will have to take sodium benzoate solution, for 10 minutes you will have to shake the powder so that the powder present in the tablet powder goes in the solution, in sodium benzoate solution, and then titration is performed. So here you are eliminating the use of two organic solvents, chloroform class 2 organic solvent and ethanol class 3 organic solvent. Now, similarly, these drugs can be titrated, or they can be analyzed by use of hydrotrophic solutions to replace acetone, ethanol, dimethyl formamide, etc. Now, coming to the UV analysis. Now, for UV analysis using hydrotrophy, the example is that of tindazole tablets. IPPP method includes this method, as the students might be knowing that 20 tablets they are weighed, and then average weight is determined, and then they are triturated to get powder, and then that powder is used for the analysis. So here the method of IPPP method is weigh tablet powder equivalent to 0.15 gram of tindazole. This is shaken with 20 ml of methanol in a 100 ml volumetric flask. After sufficient shaking, then volume is made up to 100 ml with methanol. Then filtration is done to remove insoluble excipients. From the filtrate, you will take 10 ml and dilute it up to 100 ml with methanol. So you will, and from this solution again, you will take 10 ml and it will be diluted up to 100 ml with methanol. The absorbance of this solution is noted at 310 nm against methanol. Because here total the solvent system is methanol, so in the reagent blank you will put methanol, and in the sample cuppet it will be that solution of drug together with it methanol. So in this way you have noted down the absorbance at 310 nm, which is means the peak of tindazole comes at 310 nm in methanol solvent. Calculate the content of tindazole taking 356 as the specific absorbance at 310 nm. This means this E1% 1 centimeter value of tindazole in methanol is given, that is 356 at 310 nm. Using this, you can find out the drug content of your tindazole tablet. The total method is methanolic method. Methanol vapors, they are harmful. It is class 2 organic solvent. Now, this methanol will be replaced by hydrotrophic solution. So in eco-friendly analysis, what you will do, weigh tablet powder equivalent to 50 milligram of tindazole, add 20 ml of 30% weight by volume aqueous sodium benzoate solution and shake for 10 minutes in a 25 ml volumetric flask. So what you are doing in a 25 ml volumetric flask, you have transferred the tablet powder, and then you have added 20 ml of 30% weight by volume aqueous solution of sodium benzoate. You are shaking it for about 10 minutes. During this 10 minutes of shaking, whatever the tindazole is present in the tablet powder goes in solution in this hydrotrophic solution of sodium benzoate. So, okay, then up to the mark, you will have to dilute with the water, 25 ml mark. Means only you have to use sodium benzoate only once. Afterwards, always you will have to do here the dilution with water. So very economic method, number one. Anyway, so up to 25 ml you have diluted with water. Okay, then you will filter it to remove water insoluble, you may say, the tablet excipients. Then from the filtrate you will take 1 ml and it will be diluted up to 100 ml with water. And then the absorbance of this solution is noted at 318 nm against reagent blank. Here, two things you should mind well. Here, in case of water, the peak of tindazole comes at 318 nm. In case of methanol, it was 310 nm. Due to change in solvent, there is shifting of peak. So here in aqueous system, you will get peak at 318 nm. So what you have done, you have noted the absorbance at this 318 nm against reagent blank. So from the point of view of students, let me explain how will you make this reagent blank. This will be made in this way. You will take 25 ml volumetric flask, 20 ml of 30% weight by volume solution of sodium benzoate in this flask, up to the mark means 25 ml, you will dilute with the water. Then you will take 1 ml from this and dilute up to 100 ml with water. So this is the reagent blank for this. What does it mean? This reagent blank solution contains the same concentration of sodium benzoate as is present in the sample solution together with drug. So in your sample solution, the drug plus sodium benzoate is there. In the reagent blank, the same concentration of sodium benzoate is present. So since both cuvettes contain same amount of sodium benzoate, so there is neutralization of effect on absorbance. Okay, like this. So now what you have done up to this time, you have noted the absorbance at 318 nm against reagent blank, number one. Now how to find out the drug content now? Now you see the last para. Calculate the content from the absorbance obtained by repeating the whole procedure using 50 milligram Tindazole RS in place of tablet powder. This means, what is this Tindazole RS? Means reference substance. So means whatever the sample of Tindazole you get from the industries as gift sample, etc. So that is written that how much percent of Tindazole it contains, like maybe that it contains 98.78% of Tindazole, it may contain 99.23%. and so on and so forth. So based on that, he will take 50 milligram of Tindazole in a 25 ml volumetric flask, 20 ml of sodium benzoate solution, 30%, seeking to dissolve it. When you get a clear solution, volume is made up to 125 ml with water. 1 ml of this solution diluted up to 100 ml with water. Then this is the solution of which the absorbance you have to note at 318 nm against the reagent blank. So reagent blank in this case and in previous case they are same anyway. So what you have done, you have noted the absorbance of standard drug solution here, and now by comparison of these two absorbance you can find out the drug content of your tablet. This is one procedure. Another procedure, you may make 5, 10, 15, 20, 25 mg per ml drug solutions, and respect to reagent blank you will have to use. Reagent blank will be different for 5, it will be different for 10, because they will have different concentrations of sodium benzoate. So 5 reagent blank 5, 10 reagent blank, like this you will note down the absorbance, 5 absorbance you have got. Using these absorbance you can get the regression equation, and using that regression equation also you can find out the drug content. Now main thing is that here the sodium benzoate does not interfere in UV estimation above 292 nm. If you take concentrate, means say 1000 mg per ml solution of sodium benzoate, if you see the skin from 200 to 400, from your side you see 200 to 400, the absorbance is 0 at about 292 nm. After 292 nm, there is no absorbance of sodium benzoate. So it is clear here, which you say cutoff point like this. So anyway, so at above 292 nm, sodium benzoate does not interfere. So for all water insoluble drugs which have good solubility in sodium benzoate solution and which have peak above 292 nm, you can easily estimate. For example, that of metronidazole benzoate or metronidazole 320 nm, ornidazole 319 nm, naproxen 331 nm, norfloxacin 324 nm, like this. So in this way, water insoluble drugs, those which are having good solubility in sodium benzoate solution, can be estimated at you will say the peak above 292 nm, not before that. Okay, so in this way sodium benzoate does not interfere in your estimation, UV estimation. If you have any question, please note down. At the end of the lecture you will have question answer session. Naproxen tablets, IPPP method, methanol they use methanol, sodium benzoate has been used to replace methanol. Indomethacin, methanol is used, IPPP method, sodium benzoate can be used because indomethacin is estimated at 320 nm, at which sodium benzoate does not interfere. Naproxen 331 nm, no interference of sodium benzoate. Diazepam capsule 354 nm, methanol can be replaced by mixed hydrotropy. Similarly, atenolol tablets and diclofenac sodium tablets, IPPP method, they use methanol, but in our method, hydrotropic method, urea solution, I have utilized the concentrated urea solution because urea does not interfere above 240 nm. And here in case of atenolol, estimation is done at 275 nm, which is away from 240 nm of urea cutoff point. And for dichloronic sodium, it is 276 nm, no interference of urea here. But you cannot use sodium benzoate in these cases. So urea, which gives a good solubility, hydrotropic solubility for atenolol and dichloronic sodium, has been utilized for UV estimation of these tablets of these two drugs. So anyway, in identification test also we can utilize. Now I am having about 10 minutes to finish the lecture. Now in case of TLC without any organic solvent can be employed. Here you see the reference of the published paper. M.Pharma students have done this work. Okay, what they have done? They have utilized 9 water-soluble drugs like propranolol, hydrochloride, guaifenesin, then your last low sodium potassium. So 9 water-soluble drugs were utilized in this particular study to carry out their TLC. How the TLC was performed? First, you see the blends. These blends do not contain any organic solvent. They contain only water and the solids. Blend 1, 5% sodium benzoate, 5% sodium acetate. So total became 10% weight by volume solution of sodium benzoate and sodium acetate. Okay. Similarly, blend 2, sodium benzoate and niacinamide. Blend 3, sodium benzoate and sodium citrate. Blend 4, sodium benzoate alone, 10%. So mixed hydrotropy as well as single hydrotropy, which is hydrotropy. These solutions were employed for all drugs. For example, in case of propranolol hydrochloride, this same 8 blends were utilized for each and every drug. Silica gel G was used. The silica gel G plates were used for this TLC. After spotting with 2% aqueous solutions of drug, after their drying of the spot, then they will run, means mobile phases were used to develop the TLC plates. And then after drying of these developed plates, then identification of spot was done using the iodine chamber. Okay, I told the students, you note just those blends which give a spot without tailing effect. So in case of propranolol hydrochloride, 7.5% niacinamide and 7.5% sodium benzoate mixed hydrotropic solution was used as mobile phase. RF value was 0.8. In case of guaifenesin, blend 1, 2, 3, 4, and 7, they were found good, means without tailing effect, these RF values are given. Ceprofloxacin and only 1 blend was found like this. So you are seeing that 9 drugs, they were estimated by, they were developed by all 8 blends to develop their plates. And you see up to this time, whatever the TLC is conducted, always at least one organic solvent is there, as you are seeing here the examples of 5 drugs. Ceprofloxacin hydrochloride IP method for TLC include dichloromethane, methanol, acetonitrile. In case of guaifenesin, carbon tetrachloride of class 1 and ethanol class 3 means there. Piperazine citrate, acetone is the organic solvent here. So in this way, up to this time, whatever TLC will see, in all TLC, always one or more organic solvents are there. Now you listen one sentence from me that for each and every compound, means whether it is water soluble, water insoluble, you can carry out the TLC of that particular compound using hydrotropic solution, mixed hydrotropic solution, or mixed solvent systems. Okay, so for all compounds this can be done, and for B.Pharm students, second year, third year, final year, they can easily perform the TLC. So a small research work can be done within 3-4 days. Okay, and very economic methods are there. So with a good objective that without organic solvent you can carry out the TLC. So anyway, with this object, the small projects can be performed by the students. Now after TLC, now HPLC. In case of HPLC, of course, there are limitations. But for all water-soluble compounds, you can perform the reverse phase HPLC. First, you see the reference, this one. Here, this work has been done by Remy S.L. Madam. She is there in Kerala University. She has done her PhD on hydrotropic analysis, UV analysis, and HPLC. She has estimated cefixime tablets using hydrotropic solution as mobile phase to carry out reverse phase HPLC. What she has used? Mobile phase, 6% bit by volume aqueous solution of sodium acetate, adjusting the pH to 6.2 with acetic acid. Okay, now let me explain, because some of your students and teachers, they are interested in to see this HPLC, how HPLC can be carried out without the use of organic solvent. So let me explain first here what Remy Madam has done. I told her to use 4% sodium acetate, but I think she could not get good results using 4% sodium acetate solution in water. So she has employed 6% weight by volume aqueous solution of sodium acetate in water as mobile phase. But since the pH of this solution alone 6% weight by volume sodium acetate solution, the pH is about 8 or 8.5, something like some slightly alkaline. And we know that slightly alkaline solutions will have destructive effect on the life of your columns. So she has brought this pH to 6.2 with acetic acid. Okay, then this solution was employed as mobile phase to carry out the reverse phase HPLC of this cefixime tablets. Okay, so here you are seeing there is no acetonitrile, no methanol, etc. No organic solvent is there. The one thing should be kept in mind by all the students and teachers that, as I told you, that solids also possess solubilizing power. As your methanol is doing, as your acetonitrile is doing, the same thing can be done by the molecules of solids also when they are in liquid state. They can be involved in hydrogen bonding weak one or forces to increase the solubility and all that. So they can have the same solvent type of effect. That's why this analysis was successful. So first let me, these are some of the, you may say the details of this paper, but what you should do, since your interest is in reverse phase HPLC, so the students and teachers, they can use this reference. In this reference, this is available online. You can see this one. Okay. Now another paper, the same, the Remy madam has done this work also. Simultaneous analysis of tablets containing two drugs simultaneously, means paracetamol and diclofenac, means tablets containing two drugs simultaneously. These tablets were estimated by Remy madam using this reverse phase HPLC. And what she has employed mobile phase, she has used 5% urea solution. And this 5% urea solution was used as mobile phase to carry out the reverse phase HPLC of these tablets. And of course, this full paper is available online, so you can note down your this reference. And those who need, I can give you PDF. I can send the PDF to you also. Okay, and in this particular paper, she has done so many validation parameters also. It is a big paper. Okay, one more thing, let me tell you. Actually, I should not say, but then also let me explain you. The guide of Remy madam was not pleased with her work because she was of different branch. I'm not telling the name, I'm not telling the branch, but not from chemistry branch. She was always having doubts on the work of Remy madam. So one day what she took the help of a chemistry madam to give unknown sample to Remy madam, and Remy madam carried out this reverse phase HPLC of the compound, and the percent she has given was same. Then of course the guide of Remy madam was very happy with Remy madam work and all that. Anyway, chaliye, now coming to the mixed hydrotropy. I told you that hydrotropy is about 100 years old concept, but no one has started mixed hydrotropy before 2008. In 2008, from India, from Indore, of course, particularly from my institution, this mixed hydrotropy work on mixed hydrotropy was started. And why this work was started? First, let me explain that thing. Up to this time, I told you from 100 years, so many research papers have been published on hydrotropic say formulations and all that. Since a large concentration of hydrotropic agent cannot be employed in marketable formulations. So, of course, so many persons, they have developed injections, etc., using large concentration of hydrotropic agents, but they could not be marketed. Of course, they were stable, वगैरह वगैरह बहुत सारी चीजें थी, but they could not be marketed. So, I am giving now a method which can be used to make the marketable formulation. So let me explain this using the aqueous intramuscular injections of poorly water soluble drug. How can you make intramuscular aqueous injections of poorly water soluble drug using mixed hydrotropy? Now you see, as per Inacto Ingredient Guide book 2020, Of course, this book is followed by the pharmaceutical manufacturer. They observe that what is the concentration of additives which can be employed in a marketable formulation. Means this gives idea that how much percent is safe from the point of view of toxicity. So I have brought for you these 19 additives which are employed in aqueous intramuscular injection safely. Means they are safe. Now, out of these safe agents, I will tell you how the mixed hydrotrophy can solve your problem. Problem is the toxicity issue can be solved by mixed hydrotrophy. How? In place of 30, means you cannot use 30% sodium benzoate solution to develop the intramuscular injection of poorly water soluble. They cannot be marketed because you see here on the number 13, sodium benzoate 10%. You cannot exceed 10% in intramuscular injection. In active ingredient guide, the maximum limit they have given is 10%. Means if you take high concentration, then you will have to do so many study. All these things will be there. But in other words, we can say 10% sodium benzoate is safe in intramuscular injection. Okay. Similarly, you see number 8, sodium acetate 10%. It is also safe. This is also a hydrotrophic agent. Number 2, sodium citrate 10%. It is also safe in this concentration. Now, in place of 30% sodium benzoate solution alone, you will take 10% sodium benzoate, 10% sodium acetate, 10% sodium citrate. So total became 30%. Now, in this solution, the drugs, the solubility of so many poorly water soluble drugs can be enhanced sufficiently. And for those drugs which have good solubility, desirable solubility in this particular mixed hydrotrophic solution, you can make it's a aqueous intramuscular injection. And here all these 3 hydrotrophic agents are in safe concentration, so this injection can be marketed. And this mixed hydrotrophy is being used in Egypt by Dr. Hussein Misri. He is still using mixed hydrotrophy to develop the marketable formulation. After my work on mixed hydrotrophy in the year 2008, now he is still using. I have delivered a lecture of 90 minutes to him alone, and he is still using mixed hydrotrophy to develop the formulation and so on and so on. Anyway, so mixed hydrotrophy can be utilized to make marketable formulation. In place of 3, you can use 4 in smaller concentration. You can use 2 like this. By mixed hydrotrophy in the safe concentrations of hydrotrophic agent, you can increase the solubility of drugs to develop their aqueous intramuscular injection in the form of solutions. Okay, so one more thing I will explain here itself. Just within 5 minutes, I will try to finish my lecture. Now you see this mixed solvency concept, which I started in the year 2009. There are 2 parameters. Number 1 parameter says that each and everything present in this universe has got solubilizing power. Since all materials possess solubilizing power, so definitely the additives should also possess solubilizing power. So the second parameter of mixed solvency concept says that if you make a concentrated solution using small concentrations of several additives, making a concentrated solution, this can also increase the solubility of poorly water soluble drugs. And now I will tell you, you can make innumerable safe solvent system using mixed solvency concept. So here I will explain with the help of aqueous intramuscular injection additives that if you are going to develop the intramuscular aqueous injections in the form of solution of poorly water soluble drugs, what should you do? Since these additives are safe in from the point, means they are safe in your formulations. So what can you do? You can make innumerable safe solvent system out of this 19 list. Number 3, if you use number 1, alcohol 10%, sodium citrate 10%, arginine 10%. This is a 30% solution mixed solvent system. In this, the solubility of a particular drug, if it is enhanced to desired level, you can use it safely. Now you can change the composition. In place of arginine, you take histidine. So it's alcohol, sodium citrate, histidine 10%, so 30%, another blend is ready. So just by permutation combinations from this small list, sometimes 7%, sometimes 4 agents, you may say 7.5, 7.1 like this, 5%, 10% like this. So total about 25%, 30% concentrations, you can make innumerable safe solvent system, and they all are safe from the point of view of toxicity, and they will have different solubilizing power for a particular drug. So in this way, innumerable safe solvent systems can be developed by use of mixed solvency concept. Now again, I am coming to mixed hydrotrophy. Please see here, these are the results of a research done by Hitesh Jagwan in 2008. 40% urea, 40% sodium citrate, 40% sodium benzoate, or 40% sodium citrate. The solubility of furosemide was this one. When 15-20 blends were made in of different composition, different percentages of these 4 hydrotrophic agents, making it a 40% only. Solubility studies were done. Sometimes as additive solvent character were found, sometimes synergistic. So out of those 15-20 blends, I am giving the information about the 3 blends. Number 6, 15% sodium benzoate, 5% sodium acetate, 5% sodium citrate, 15% urea. Solubility is 4.2%, which is double than that of the solubility in sodium benzoate. Means here the synergistic solvent action is there. Just by saying, by here in short, I will say that by using mixed hydrotrophic solubilization, sometimes you will have additive effect, sometimes synergistic, and you can develop your marketable formulation. Now, another parameter example is this one. I have made this mixed solvent blend. pH of this blend was 7. 4 solids were implied in 5%. Sodium benzoate, sodium caprolate, sodium citrate, Pulaxamar 407, total 20%. And neutral pH. The solubility of several drugs was checked by me. Out of those, I am giving the information about these 2 drugs. Furosemide solubility in this particular blend was more than 35 milligram per ml, but in water it was less than 1 milligram per ml. So at least 35-fold enhancement solubility is there. Why this solubility enhancement is there? The reason is again the same. For all these 4 solids, their molecules are present in liquid state for hydrogen bonding and weak van der Waals forces with the molecules of solutes. So in this way, there is solubility enhancement. You are seeing by 4 solids, they are increasing the solubility. Pyroxicam solubility 20 milligram per ml in this blend, but in water 1 milligram per ml, 20-fold enhancement solubility is there. What can you do by use of mixed solvency concept? Just briefly, dry powder injection for reconstitution, published paper reference is there. Candesartan Selexatil 8 milligram dose. 3 solids were employed, they were kept in the vial. When you add 1 ml water, you get a clear solution after reconstitution. Very good objective, means very good work. Means this type of projects can be done in your college also. Published paper references there. Those who are interested, I will give other references also. Solid dispersion can be made with the help of mixed solvency concept. Torsemide insoluble drug, and these solids were implied in solution. They dissolved torsemide. Water was removed and dry solid dispersion was made for fast release of this torsemide. Published paper, always in all these work you will get published paper which are available online on Google search. Liquid solid system can be made with the help of mixed solvency concept. Here pyroxicam solubility in propylene glycols was less, but it was improved with the help of solubilizing power of 2 solids, sodium acetate and sodium the sodium caprolate. And then in a small volume, the dose was there, which was absorbed on MCC, and then liquid solid systems were made for fast release. Aqueous injection can be made. Dry powder injection, this is another work, published paper is there. Then this I have explained to you. These are the tables, of course, which will be used later on. Metronidazole was used in soluble drug in vaginal film to decrease the size of vaginal film by increasing the drug loading. Improvement of drug loading in ACDDS. All these are M-Pharm projects. I can send to you the soft copy of thesis also if you require. Drug loading increase in oral films. Again, oral film. 2-3 minutes for this example, that solids can be implied for the extraction also. This is also very interesting work. Now you see directly I am coming to the work. This is the published paper. What is the reference? Eco-friendly extraction using solids in novel application of mixed solvency concept. Published paper reference is there. Briefly, I will explain what was done. Sesame oil has got very poor solubility in ethanol. It is good solvent, means means hexane is good solvent for sesame oil. So by the pharmaceutical this oil producers company, they use hexane for the extraction of the sesame oil. When hexane is removed, some traces may be there which are harmful for human being. Now I will tell you, and of course sometimes they use ethanol and hexane mixture, producers of this sesame. Because ethanol is a poor solvent for this sesame oil. Means ethanol cannot be implied. Ethanol is a class 3 organic solvent. It is safer, but it cannot be implied because of limited solubility of sesamide. So again, I am giving one example that how can you potentiate the solvent power of a mixed solvency concept. I will tell you by use of solid solubilizers. Okay, so here first you listen that blend of hexane together with ethanol, and then they extract out the sesame oil from sesame seed powder. Then ethanol and hexane, they are removed, but then also traces of ethanol and hexane may be there. So what they have done, they have made ethanol a strong solvent by use of hexane. But now here in my example, I will tell you how can you increase, how can you potentiate the solvent power of a class 3 solvent to act as a class 2 solvent like hexane. I will tell you now. Now you listen to me. Our M-Pharm team students, they have checked the solubility of sesame oil in melted thymol. 1 gram melted thymol at about 50 degrees centigrade, 50 degree per clear colorless liquid of thymol nicely dissolves more than 1 ml of sesame oil. Means very good solvent, melted thymol. The extraction: 3 gram sesame seed powder, 9 gram thymol in test tube, water bath at about 30 minutes shaking during this melted condition of thymol. Melted thymol has extracted out the sesame oil present in the sesame seed powder, then straining through cotton cloth, and strained liquid was exposed at about 60 to 70 degrees centigrade to remove thymol. Within 1 hour, all the thymol was nearly all complete removal of thymol was there. Of course, some traces of thymol were there in the sesame oil. Okay, so in this, what we are seeing, the melted solid is acting as solvent to extract out the active constituent from the sesame seed powder. Another is similarly melted thymol has been used for the extraction of sesame oil. It was removed in 1 hour at 68-70 degrees centigrade. Now you see how can you make ethanol, means class 3 organic solvent, to act as class 2 in solvent power. Like now you see number 3, 50% weight by volume thymol in ethanol solution. Very good solvent for sesame oil. 1.4 ml is nicely dissolved by 1 ml. Means very good solubility of sesame oil in this 50% weight by volume thymol in ethanol solution. Now, so what you are seeing here, there is comparison with hexane, class 2 organic solvent. Here, ethanol, when you are using a solid thymol, so that because of the solubilizing power of thymol, ethanol becomes a strong solvent like hexane. And now this solution means thymol in ethanol solution was employed for extraction. How? 3 gram sesame seed powder, 9 ml of this solution at room temperature. This solution extracted out the sesame oil from sesame seed powder, straining through cotton cloth, and strained liquid was kept in oven at 60-70 degrees, and all ethanol, nearly all ethanol and thymol, they were removed. Remaining was sesame oil containing small traces of thymol, small traces of ethanol. So now you make comparison. Here the traces of thymol are there. In hexane case, there were traces of hexane. So here thymol is safe. Of hexane. Anyway, so in this short explanation, I can say you that solids can also be implied for extraction of active constituents. Now my lecture is nearly over. Now, but some information to the students and teachers that my 7 YouTube videos of each of about 40 to 45 minutes duration. So what you will get on YouTube, if you put these words on Google, this eco-friendly lecture series number 1. So you will get the UV analysis, eco-friendly and economic UV spectrophotometric analysis of hydrotrophic mixed solvents concept without the involvement of organic solvent. Just like this, if you put word 2, okay, so here you will get titrimetric analysis. Those who are interested for this, they can see this video. Number 3, it is for mixed solvency concept. Each and every substance, whether the gas, liquid or solid, present in this universe has got. If you put word 4 in this, you will get TLC details. So those students and teachers interested in TLC, they can see this one. Number 5 is for reverse phase HPLC. So those who are interested for reverse phase HPLC, they should see this number 5 video. Number 6 is for dry powder injection for reconstitution. Those who are interested to carry out this MPhAR project work or in PhD, they can see this one. Number 7 is for how can you make innumerable eutectic liquids. It is also an art and very good art. So those who are interested to synthesis for analysis for formulation, etc., they can see this one. Now these are some of the information about the review articles. This is again a review article. This is a book which has been published in the year 2020. It has chapter number 5 on hydrotropy, mixed hydrotropy and mixed solvency concept. Now then, thank you is very important here. Now and here, mobile number is there. So those students who are interested for all this work and teachers, they can note down this WhatsApp number. They can contact with me. They can ask this presentation from me using this. Okay, now I am coming to you to deliver the to give the answer for your queries. Stop sharing कर दो, कुछ हम भी बता देते.
Thank you, sir, for this informative lecture. Now, I would like to call Dr. Vikrant Verma, sir, Associate Professor in Department of Pharmaceutical Chemistry, Kharwel Subharti College of Pharmacy, for question and answer session.
Good afternoon, sir, and good afternoon all the participants. And today I will be asking questions on behalf of participants. First question is, how to fix safe concentration for combination of mixed hydrotropes in formulations? This question is asked by Selja Rangoli.
प्रोग्रेस में भी आ रहा हो ना वहीं से.
Yes, sir.
हाँ, बस ये आ गया.
Sir, I will be asking questions on behalf of participants. Good afternoon, sir. Sir, I am audible?
हाँ, audible.
Sir, I will be asking questions on behalf of participants. Good afternoon, sir. Sir,
Okay.
Sir, how to fix safe concentration for combination of mixed hydrotropes in formulations? This question is asked
Okay.
by...
Okay. And you see, the marketable formulations using hydrotropy can be developed with the use of hydrotropic solubilization. You see, up to this time, I told you that hydrotropic solubilization is 100 years old concept. So many persons, they have developed, say, intramuscular injections of so many poorly water soluble drugs using single hydrotropy. Some persons, some researchers, they have used sodium benzoate solution 30%, 35%. Some have used sodium salicylate solution 30%, 35%, etc. And they have made the injections. But since more than 10% sodium benzoate is not allowed as per inactive ingredient guidebook, as I have, which give the list of 19 additives which are used safely in that concentrations in intramuscular injection. So in that list, I have shown you that 3 hydrotropic agents were there: sodium benzoate 10%, sodium citrate 10%, sodium acetate 10%. So if you combine these 3, making a 30% solution, this can be implied to develop the intramuscular injection. You can also take 8%. If it increases the solubility, then also you can use. But above 10% cannot be used as per an inactive ingredient guide. These 3 hydrotropy agents, what I want to tell you. So mixed hydrotropy, if you develop, means if you increase the solubility of your insoluble drug sufficiently to the desired level, then you can formulate its intramuscular injection. And after making its intramuscular injection, you will have to carry out the chemical stability studies and physical stability studies and all that. Of course, if you carry out the toxicity studies, then also you will find them to be safe, no problem. So mixed hydrotropy can solve the problem. Okay, and still you can use more number of hydrotropic agents, but you should see inactive ingredient guidebook before thinking their use in your formulation. Means they should be there in inactive ingredient guide. So it will be a safe way, a simple way to develop the intramuscular injection. If you want to develop say syrups etc., then also you should see the inactive ingredient guide, how much maximum percentages of these compounds can be employed as additive in your formulation. What we are doing, we are implying these as additives. These hydrotropic agents are additives which are employed in intramuscular injection, and they will give the solubilizing power due to the same reason that solids also possess solubilizing power. Whether you say it is hydrotropic solubilization or you say due to solubilizing power of solids, because the molecules of solids, they are available in liquid state.
Sir, one more question is there by Kunal sir.
Yeah.
Sir, there are any difference between a hydrotope and surfactant in enhancing solubility?
Of course. You see, number one, hydrotropy, in case of hydrotropy, whatever the researchers have given in their published papers, they say that in case of hydrotropic solubilization, the reason for solubility enhancement may be. How it may be? The reason for solubility enhancement in hydrotropy may be due to planar aggregate formation. Maybe due to co-solvency, maybe due to salting effect, maybe due to physicochemical interaction. Means one mechanism, they say due to planar aggregate formation. In case of surfactants, the micelles are spherical. We know this is polar part, non-polar, polar, non-polar, like they are the spherical aggregates of about say 60, 70, 80 molecules of surfactant. So they are known as micelles, they are spherical. And the reason for solubility enhancement by surfactant or micellar solubilization is due to either adsorption of the molecule of solute which is adsorbed on the micelles, or partitioning in the micelle. But here in case of hydrotropy, they say it may be due to planar aggregate formation. From the point of view of some of the researchers who are working on hydrotropy, they say that there are chances that planar aggregates are formed which are responsible for solubility enhancement by hydrotropy. But I will tell you the definite, till actually up to this time, whatever the mechanism they give in published papers, you will find maybe, and in the last they say that till now there is no definite mechanism of hydrotropic solubilization. But I give the definite mechanism is that all solids also possess solubilizing power. Okay, suppose you see this hydrotropy work has been carried out from 100 years old when Newberg etc. they do the work. And at that time, the scientists, they are researchers, they did not have this, you may say, the clarity that solids also possess solubilizing power. Why this hydrotropic solubilization has come in the picture? The reason is sometimes they have used sodium benzoate, it has increased the solubility in water, sodium acetate, sodium citrate, urea, niacinamide, etc. They increase the solubility, and it was not in their mind that solids may also possess solubilizing power. That's why some new term they have started, hydrotropic solubilization. Suppose they were up thinking that all materials possess solubilizing power due to hydrogen bonding, weak van der Waals forces, then this new term must have not come from, okay, and all hydrotropy and whatever the things are there, they all possess solubilizing power. So if you see in this way, surfactant solubilization is also comes under mixed solvency concept. But since in our books, they give it in a different way, that's why at this time, we are not making this mixed solvency concept useful here, to be used here until unless it comes in books. Up to this time, we will take micellar solubilization separately. We'll have to consider hydrotropic solubilization separately. So there is no actually, but from my point of view, all these things come under mixed solvency concept, whether it is hydrotropy, whether it is micellar solubilization. One more thing, let me explain you. In water, when surfactant comes, we say that micelles are formed. But I say that 280, 220, they are liquid. In that also some material, if you see the solubility of some of the compounds, they will be dissolved by this twins. Then here there are no micelles. Then why there is solubilization? Or in other words, you may say, suppose you mix a twin in ethanol, and then also solubility enhancement is there. Now, why there is solubility enhancement when their micelles are not there? But here water is not there. So anyway, so many things are there. But if you believe on my concept, then you will have to say that each and every material possesses solubilizing power, and it is there. And one day will come when this mixed solvency concept will prevail in this world, and so many things or so many problems of solubility issue, they will be solved by mixed solvency concept.
Thank you, sir. Thank you very much for your information. Now I'll pass my Nandini ma'am to carry on.
Thanks a lot, sir. Now, I am inviting Dr. Manish Kumar Pathak, sir, Associate Professor in Department of Pharmaceutical Chemistry, for presenting word of thanks to our speaker.
Thank you, Nandini ma'am. Jai Hind to all. I would like to express my gratitude to Dr. R.K. Maheshwari sir, speaker of the webinar, for their presence and their contribution to make the webinar successful. I extend my gratitude to our Honorable Vice Chancellor, retired Major General G.K. Thapaliar sir, our CEO, Madam Professor Dr. Salya Raj ma'am, for inspiring and encouraging us. Thanks to our principal, Professor Dr. Sukhinder Kumar, for providing immense support to make the webinar successful. I must thank the departmental organizing team, all pharmacy faculty members, PPD and Marcom department, especially Mr. Akash Bhatnagar, Ms. Mariam, Mr. Jatinji, Mr. Ayushji, for work hard for the past few days to make this event successful. Lastly, I congratulate all 329 participants for their active participation. Thank you everyone once again for making it a successful. Jai Hind. Thank you.